Hi everyone, I'm Swati and welcome back to my channel. We are on a series of mechanics. We are learning vectors and today's video is all about union vectors, components of a vector, resolution of a vector and some basic concepts in numericals. So let's begin with that. Okay, so let's start with our first topic, that is unit vector. So what is unit vector? We have discussed a little bit of unit vector in our first video when I discussed the types of vector. So basically a unit vector is something which has a magnitude of one unit. That's why the name is unit vector, because it is a magnitude of unity. And second, its direction is in the direction of a given vector, is in the direction of given vector. Okay. Next, it was denoted by a cap. Denoted by this a cap, and you can calculate. You can read it as a cap or a hat, and it has a formula of. You can calculate this unit vector by dividing the given vector from to its magnitude. Okay. Now, if you want to understand where we have to use this unit vector, so it is like that. Suppose you are given this a vector, okay, and it has some magnitude and a particular direction. Now you want a new vector which has a direction in this along this a vector only, but has some other magnitude. In that case, what you have to do, you have to calculate the unit vector of this. If you calculate its unit vector, then you have a vector whose magnitude is 1 and direction is along this a vector. Okay, so if its magnitude is 1, then you can multiply it by any scalar number lambda, and you can get a new vector b which has a magnitude of this and direction is along a vector. Okay, so whenever you've been asked to get a vector in a direction of a particular vector, so you have to calculate its unit vector. Now, the most important thing for the Cartesian plane, which has a high usage in mechanics, whenever you have to define the position of a particle like in 2D or 3D, you have to use this x, y, and z components. So you have to write it in a vector form. So what the physics has defined a unit vector along these x, y, z direction. That means along x direction, you have a unit vector of I cap, along y it's j cap, and along z it's k cap. So this I cap, j cap, and k cap are the unit vectors whose magnitude is obviously equals to 1. And if you want to see the direction, that means I cap is along x-axis, j cap is along y-axis, z cap is along k cap is along z-axis. Now you can learn is this. Let's suppose an object has a position vector of 3 I cap. Then what you will say, that it is at a distance of 3 units, 3 meter, 3 centimeter, whatever the scale you have chosen, along positive x-axis. Along positive x-axis. Now, if this is along minus 3 I cap, then it is along negative x-axis. So, positive I cap, j cap, and k cap, let's say, plus I cap is along positive x-axis, plus j cap along positive y-axis, plus k cap is along positive z-axis. So you have a negative of that when the direction opposites. The positive become negative. We have already discussed that. So when you are using minus x-axis, you have reverse the direction. The minus sign automatically comes there. It's minus y-axis and minus k cap is minus z-axis. Okay, so it is something like that. Now, let's have some basic thing. Suppose you have given that the vector has a magnitude of 5 units, magnitude of 5 units in positive x direction, in positive x direction. Then how you will write its vector? It's simply, you don't have to write plus I cap. Okay, if they say magnitude of 10 units along minus z direction, then how will you write? It's simply 10, but it's minus z, then it is minus k cap, then it become minus 10 k cap. Okay, now since we are learning mechanics and it is one of its tools, so you have to deal with 2D 3D things. So now you can suppose that the object is somewhere here in 3, 2. Okay, so you have done your previous classes that the Cartesian plane, the first is your x, second is your y, and third is your z when you define this coordinate system 3, 2, 1. Let's see. Okay, so that means it has a component of 3 along x-axis, a component of 2 along y-axis. So how can you write that? 3 I cap plus 2 j cap. Okay, so it is somewhere there in xy plane where it has a component of 3 along x-axis, a component of 2 along y-axis. And suppose if it is in a 3D plane, a particle is in like 1 comma 2 comma, let's say minus 2 comma plus 3. So you can simply write as 1 I cap minus 2 j cap plus 3 k cap. And it's like you can write 1 or you can simply write it as I cap minus 2 j cap plus c k cap. So 1 is like by default thing. It's understandable. Okay, so this is how you write a unit vector xyz whenever you have to define the position of any particle, which we will learn in kinematics later. So you have to use this I cap, j cap, and k cap to define the position of a particle. And I cap, j cap, k cap define the components of that particle, of that position of the particle in terms of I cap, j cap, and k cap. So yeah, it has this usage. Now, for example, you have to calculate let's say you have given this a vector, obviously in terms of this I j k cap only. Let's say I cap plus 2 j cap plus 2 k cap, and you have to find its unit vector. No, what does it mean? It means that this A vector has a magnitude of 1, a magnitude of 2, a magnitude of 2 along x, y, and z direction. And that means it has some net effect. It has some magnitude. Net effect means it has some magnitude. Its magnitude is not 1. So if you want to calculate its unit vector, we have to divide this vector with its magnitude. So to calculate this magnitude when it is in terms of this I cap, j cap, and k cap, when it is in this term, so what you will basically do, I have told you that to calculate the magnitude, the resultant, you have to use that thing, a square plus b square plus 2ab cos theta under root gives you what? This unit vector. Okay, now you don't have to remember this. You have to just remember that I cap and j cap are along x-axis and y-axis. These are two vectors. First, take these two vectors because I have told you that this formula is valid for two vectors. Now understand this thing, that I cap and j cap are along x and y-axis, that they are perpendicular to each other. That means theta is here 90 degree. So this whole terms will goes to 0, and then your r vector will simply be a vector plus b vector. That means I cap plus j cap. That means 1 square plus 2 square. Take the magnitude. Now, when you take this, you will get what? 1 plus 2 to the 4, that is root 5. Now you have to calculate this with 2I cap. Now this resultant will go with this. Now understand it. The xy resultant will give me a resultant along its diagonal. Okay. If xy are the two sides of a parallelogram, then it's resultant along the diagonal. Now this diagonal is also will be in this xy plane. Now if you talked about z, so if it is xy plane here, the resultant is also in that plane. But your z axis is perpendicular to xy plane, which is also perpendicular to its diagonal. Okay, that means if you have to calculate the resultant of this r vector and along z, again the theta is 90 degree. Then you have to do this r square plus this z square. Then this r is root 5. Root 5 square is 5 plus 2 square because that is 2. Then it is 4 and it gives you root 9. That means 3. Now if I have to make a formula out of this, you can simply say that the resultant of x a cap and y j cap. Let's break it down. First is, if you have given this a vector to be simply xi cap, x has some value 2, 3, anything, then its magnitude is simply x. If you are given in like 2D xi cap plus yj cap, then you have already seen, then you have to use this formula because the angle is 90 degree. Then its magnitude is simply x square plus y square. And if it is in 3D, xi cap plus yj cap plus zk cap, then all you have to do is you have to simply square the three things and get a root. Because if you can see here, this square, this is basically r square and again the z square. So this square removes the under root, you will get a square plus b square plus z square. So it is the same thing. So you have to remember the formula, and obviously when you deal with this mechanics, you have to deal with 1D, 2D and 3D. There is no 4D. So this is the things which you can use to get the magnitude. Okay. So now if you have to calculate this unit vector, then your a vector is what? I cap plus 2j cap plus 2k cap. I think this is, yeah. So if you have to calculate its unit vector, then you have to divide the vector, its magnitude, and the vector is what? I cap plus 2j cap plus 2k cap, and just divide this by 1 square plus 2 square plus 2 square. Then it becomes I cap plus 2j cap plus 2k cap, and this is 1 plus 4 plus 4, that is 9. Under root of 9 is 3. Then your a cap is equals to 1 by 3 I cap plus 2j cap plus 2k cap. Now this vector has a magnitude of 1 and its direction is along a vector. Now what you can do, if you being asked and get a vector having a magnitude of, let's say, 5, so what all you have to do is multiply it with 5 and you'll get a vector whose magnitude is 5 and direction is along a vector. Okay, so this is what a unit vector is. Now if we move forward and understand the component and the resolution of vector, then what its meaning? Resolution of a vector. Okay, it's simple. You have seen, if we talk about in Cartesian plane, our point is there. Let's say there is a vector A from the origin. Now, this is your A vector. Somewhere lie in this XYZ plane. Now, this A vector has a position vector of 3, 4. Now, you can say that it has some effect along x-axis with a magnitude of 3. It has also effect on y-axis with a magnitude of 4. Okay, that means this A can be resolved along x and y-axis, or you can say it can has a magnitude along x and y-axis. It can be thought like that, and the combined effect, the influence of this x and y combined gives you the net effect on this A vector. You can understand like this. Suppose an object is here, okay, and let's say a box is placed here, and object is pulling it with a force F1 here, and another object, another person is pulling it with a force of F2 here. Now it is like being pulled there. You can say that this box will move along this, the net vector effect. So here you can understand that it has some influence along x-axis and some influence along y-axis, whose combined effect give you a vector along this. Now take it in a reverse mode. Your vector is along here, so it has a component along x-axis, it has a component along y-axis, whose combined effect gives you this A vector. So this A vector can be written as this AX I gap plus AY G gap. Okay, so this AX, AY, and also AZK gap if you work in 3D, but let's work in 2D right now. So this AX and AY, what are they? Are the components of A vector. Okay, means they are the parts of A vector whose combined effect gives you the net A vector. If we move to the rectangular components of a given vector, so you can understand it that rectangular means they are perpendicular to each other. So suppose you have a Cartesian plane again, and there is some vector A. Now you have to get the projection of A vector on x and y axis. So what you will do, basically you will make a perpendicular from its end on x and on y axis. Let's say this A vector is inclined at an angle of theta here. Okay, now let's see, this is theta, or this is 90 degree, this is theta, this is hypotenuse, and if this is base, so this hits here, so this particular length is what? This is A cos theta. How? This is base and this is hypotenuse. Let's say this to be x upon hypotenuse is A vector is equals to cos theta. So this x component of A comes out to be what? A vector cos theta. Let's talk in magnitude right now. Okay. Similarly, if you have to calculate this direction, so this is theta, so this is also theta, alternate angle, this is 90 degree. Now this becomes perpendicular. Now if this perpendicular, so then its y component using this trigonometry thing becomes your A vector sine theta. Okay, so this is a rectangular component where this AX is A cos theta, and your AY is simply A sin theta, and here if you have to write this A, then it becomes AX I cap plus AY j cap, which we have understand before. Then this A can be written as A cos theta I cap, and AY can be written as A sin theta j cap. Okay, and if you want to calculate its magnitude, then this component and this component square and under root, as we have discussed earlier, then it becomes A square cos square theta plus A square sin square theta, and taking A square to be common, cos square theta sin square theta gives you 1, and under root of A square is simply A and comes out to be A. So its effect is same. So if you are given in terms of this theta angle, you can write it as like this. If you are given in like a coordinate form, you can write it like this: 3I cap plus 4j cap. So they are the different form to write, but in totality it means that a given vector has different parts, have different components along xyz direction, and when you combine them, it gives you the net A vector. Okay, so it depends also where your A vector is there. It can be also written as let's say A cos theta. Let's do that with the diagram. Let's say, let's work in only xy plane right now. Then we'll move to, we introduce Z also. The vector is here. Okay. Now, if you want to and make an angle of theta from x-axis, now if you want to resolve that, you can see that it is along minus x-axis but positive y-axis. Then here this A vector is A cos theta minus I cap. A cos theta minus I cap plus A sin theta j cap. Okay, now if it goes there, then you can set resolve here, and here means along negative in this direction. Again, make theta angle with x-axis. Then this A vector will become A cos theta minus I cap plus A sin theta minus j cap. And if it goes to there, then it in positive axis and negative y-axis, then this A vector will become A cos theta plus I cap, A sin theta minus j cap. Okay, so it's simple Cartesian thing, coordinate system. Now, if you want to see the direction, what you will do, you can simply divide AX by AY. Here, theta is your tan inverse AY by AX, simply. This also we have learned in our last videos when we discussed about the addition. So I have talked about these three cases. So in the 90-degree, the direction simply AY by AX. So AY is A sin theta by A cos theta, and sin theta by cos theta gives you tan theta. It's like that. Okay. So if it is negative, you have to use a negative. It is 135-degree or in second and fourth quadrant. Like that. We will understand that when we'll do numericals. But yeah, it's there. Now, suppose your vector A is somewhere here. It's not from origin. Okay. Then also you have to make this imaginary thing and make an angle theta. And you have to see that this is its x resolution and this is its y resolution. This is AY and this is your AX. Again, AX I cap, AY J cap, whatever distance is this. There is a thing. Okay. A tip, a little tip here. Suppose in any Cartesian plane or anywhere, yeah, don't make the Cartesian plane. Let's say your vector is there and it's making an angle theta here. So with the line, it making an angle this theta, that line has a resolution of a cos theta, means always cos theta, use cos theta where the theta is there, and the other perpendicular goes with sine theta, always like that. Suppose your vector is here, let's say this is the b vector, it makes an angle of theta here, then this line with which it makes an angle theta becomes b cos theta, and other perpendicular to this line will goes with b sin theta, and you will get b cos theta and b sin theta perpendicular to each other. Okay, first thing is this, always take cos theta with the line which makes an angle theta with the vector. Second thing is, if you work with wedge, you will do that when you learn Newton's law. Let's say an object is here and that wedge is making an angle theta. So when you will resolve that, you always have to remember, this is mg, this is the mg force which is downward. We will learn that. Okay, so if you make this perpendicular here, then this angle is always theta. How? Because you make a perpendicular there, this becomes 90 degree, this becomes 90 minus theta. Now if this whole is 90, so this angle is theta. Now you have to resolve this mg here, though this is becomes mg cos theta always, and the perpendicular to this line will go there and becomes mg sin theta here. So this is a tip when you use this wedge thing. Okay, so these are two things when you want to resolve it. Next, when you have to do in 3D, then the simple components will become x, y, and z. Let's say this a vector is in your 3D plane, then this a vector can be written as ax I cap plus ay j cap plus az k cap. Okay, and the magnitude can be written as ax square plus ay square plus az square, and its direction is we'll learn in our next video. Okay, so we'll start with this 3D thing only, and we'll do numericals on what we have learned till now. So tomorrow video is very important. You will learn a lot through numericals, so stay tuned with me, and thank you for watching this video, and do like, share and subscribe for more such videos.